This video is on how to solve for a variable when you have a formula. There's two different types. We're going to talk about the first one here. The first type is a formula where there's only one term in that formula that has the variable that we're trying to solve for. We'll look at an example. Here's just some random variable, a formula. R equals 1/2 gt squared plus sg. And what you're going to solve for is t. Well, solving for t, notice there's only one term that has a t in it, and that's this term right here. It's the only term that has a t in it. So we need to isolate that term, so we're going to subtract the sg from both sides. And next what we need to do is we need to get rid of this 1/2 g, and to do that we just multiply both sides by 2 divided by g. And that will eliminate the 2, will cancel with the 1/2, and the g will cancel with the g, and you'll have it isolated. So we'll have, and then I'm distributing that 2 over g on the left-hand side. So we have 2r divided by g minus 2s equals t squared. And lastly, we need to take the square root of both sides. This does bring up an issue with formulas on the fact that should there be a plus and minus. And if you knew what the formula was for, if you knew what the letters stood for, in this case, this t is probably representing time. There is no such thing as negative time. We don't have time machines and things like that. So it would only be the positive. So there is a plus and minus because you're taking a square root, but because the formula and what that variable represents could be negative, there would only be one answer, and that would be the positive. So this is an example of one of the types, which is where you just have one term that had the variable that we wanted to solve for, and that was to isolate the variable like we've done in all other formulas that we've done in the past. But the second type is a little bit different, and that's where you're going to have two or more. In this topic and in this chapter, you're only going to have two, but the reality is in the real world, you'd have two or more terms in the formula with the variable to be solved. And those terms that have that variable, the variable would be of different degrees. You'd have, like t squared and then t to the first, or you'd have t to the third and t to the t squared and t to the first. All these different degrees of that variable. We're typically only going to be seeing a first degree and a second degree term, though, in this chapter. Here is an example of a formula that if I had h equals v sub 0 t minus 4.9 t squared, where we're trying to solve for t. So t is the variable we're interested in, and we have two places where I see the t, and in this term I've got t squared, and in the first term it's only t to the first. So let's look at that. Let's actually solve for that formula for t. And what you need to notice is that it's actually quadratic in hiding, that if we subtracted the v sub 0 t and added the 4.9 t squared to both sides, so that all of our terms would end up on the left-hand side, we end up with this equation, which, if we look at it, it's just a quadratic equation in standard form, noticing that we a t squared plus bt plus c equals 0, where your a is 4.9, your b is negative v sub 0, that's really important that you have that negative there, and our c is h. And having these three things, we then know that, if we have a quadratic equation with our a, b, and c identified, we can use the quadratic formula to solve for the variable. And so we would have t is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a, our beautiful, wonderful quadratic formula. And now we're just going to use what we know as our a, b, and c. We're going to use what we have here into the formula. And as we plug that in, we got our b there, and then we also substitute in the b, we substitute in for the a, we substitute in for the c, and once again we substitute in for the a. So now we've done all of our substitution. We now need to simplify. We've got things like the negative of a negative is going to become a positive. A negative squared, well, that would become a positive v sub 0 squared. We can multiply the negative 4 and the 4.9, and we can also multiply the 2 and the 4.9. And when we do so, we end up with this final answer for the problem. This is just the simplification of what we had up here. Let's look at another problem. And in this one, we've got a equals pi r squared plus 2 pi r, h, excuse me, I almost forgot that h there. And once again, we're going to solve for the letter r, and we say, we've got r squared in this first term here. We've got r to the first here. So we've got two terms with r in it, and they are of different degrees. If we subtract the a from both sides, and then we notice, oh, this again was one of those quadratic and hiding. There it is in standard form, where that first term, pi r squared, is just our a r squared. Our 2 pi h, I notice I changed the order so that I have the r at the end of it here, so I can see more clearly that 2 pi h is my b. And I'm adding c. To be careful about that, because when you're adding, it's an adding of a c, so you're adding a negative a. And so that's to identify that our a is pi, our b is 2 pi h, and our c is negative a. Once we know that, we're going to be using the quadratic formula, and we're going to substitute in for the b, and substitute in for the b, substitute in for the a, and the c, and the a. Then we're going to collect like terms and simplify the whole thing as much as we possibly can. So this 2 pi h, remember that'd be 2 squared, pi squared, and h squared. So we got 4 pi squared, h squared. Here I'm multiplying this, but I've got a negative times a negative becomes a positive. And what you notice is both of those terms have a 4. So I'm going to factor it out. I also split this up into two fractions, because remember, this means both this first term, negative 2 pi h, and this second group, the square root, both of those are being divided by 2 pi. I do that because it's easier to simplify my fractions. Too often, if you don't break it up, students will simplify incorrectly. So, by the way, there's a 2, that 4 that was in the square root, these 4s, when I factored them out, I factored out the square root of 4, but the square root of 4 is 2. And now my 2's all cancel. You'll notice I'm not canceling the pi here, and that's because for my final answer, I'm just going to write it as one fraction all over pi. If you did cancel your pi's here, you'd have to write it as h plus or minus, and then have this as a fraction, which is a perfectly acceptable answer as well. Here's one more problem where once again I'm looking at this and I see that I have a t squared here, and over on the the right hand side I have t to the first. So my first, and I'm solving for t again. My first step is I need to get everything on the same side, and so I subtracted the negative 0.2t and have it equal to 0. So now I can see that it is a quadratic in standard form. And there's my a is the square root of 3. My b is negative 0.2, and my c is negative 4 pi, that whole thing. Okay, and I write those down. Always identify what they are before we start this out. I even write down the quadratic. Oops, that shouldn't say. Hold on, just a second. Yeah, that shouldn't have said t squared. I fixed it. Now it says t equals negative, and then oh, I see another mistake. Just a minute. There we go. It's negative b plus or minus the square root of b squared minus 4ac all over 2a. And now I'm going to do my substitutions in there. And I see that I did do the substitution correctly. I've got my negative b, but remember this is a negative plus or minus the square root of, and there it is. I didn't write the negative here, which is okay because I'm going to be squaring it, which will make it positive anyway. But I make sure that when I did that c, I do have the negative 4 pi, so that I will remember that I have a negative and a negative here as well. So that when I simplify, I've got 0.2 plus or minus the square root of, and then I have all of this. And this doesn't really simplify easily. I mean, you know, I have a decimal, but I would just leave it like this formula. It also would make us want to think about the fact that t has to be positive. Do I really need plus and minus? Maybe I don't need the minus, but we would worry about that once we had everything else simplified here, and we could plug in our calculator and then discount any negative answers that we get. So that is the solution to this quadratic. And this one actually is, by the way, this is a numeric answer. This could be evaluated to a decimal amount. There's a number there. So this is the end of a lesson on solving formulas for a particular variable when they can sometimes be seen as a quadratic equation.